All right. Oh, one other thing I forgot to mention on the test really quickly. There were a few people, I tried to make a note. I don't know if I got everybody though. That I would prefer that when you took the test, you weren't writing it in your notebook, that those papers were detached from the notebook. There were a few people that were attached, and I know it was the first test. Please just remove those from your um, notebook and then when you take the next test. So we'll probably have another test in about 2 weeks. So, all right, so let's talk about the rest of 3.4 and 3.5. I don't know why. So we should talk about the 5-number summary. 5-number summary. Right, so the 5-number summary consists of the minimum Q1, which is quartile 1, median, which you can also think of as quartile 2, quartile 3, which is the I'm going to put this as the 75th percentile, and the max. Okay. So those are that's your numbers for your 5-number summary. The minimum, quartile 1, median, quartile 3, and the maximum. So you can think of the median as the 50th percentile, quartile 1 is the 25th percentile, quartile 3 is the 75th percentile. And you can think of Q1 and Q3 as the median of the top and the bottom half. I'll pull up a data set here in just a minute. The interquartile range is Q3 minus Q1. Well, part of me wants to just go through all my notes and then we'll talk about them in a minute. And so outliers. We talked about the geography majors at the University of North Carolina. We're going to work on finding outliers. We're going to use the interquartile range to find our outliers, and the formula for finding outliers is Q1 minus 1.5 times the interquartile range and Q3 plus 1.5 times the interquartile range. So if a value is outside we refer to these, maybe I should call these fences. Oh my goodness. Fences. If it's outside the fences, maybe I'll put that as there, then we decide it's an outlier. So I'm going to show you guys how to do that in just a minute. So we've also got box and whisker plots. Box and whisker plots. Okay. Sometimes those are called box plots. We're going to need the 5-number summary, but we use maybe I should do this here. So we're going to use the numbers of our 5-number summary. However, if there are outliers, we use the fences instead of max or the minimum, depending on which side the outlier's on. So I'm going to pull up a couple of spreadsheets here and show you guys how we're going to do this. So just as a reminder, this is, where's my stuff here? Oh, in-class worksheets, okay. We're going to start on this one first. Maybe I'll download them both. I wanted to do 3.3 first. Okay. All right, so let's say that we have a random sample of 18 collision claims. So these are how much your car costs to fix. Now, of course, when you're doing your 5-number summary, it's really helpful to sort your data. So I'm going to sort my data really quickly. And so the first thing you're going to want to do is come up with the 5-number summary. And we're already going to quiz you guys and see who's paying attention here. Alejandra, I don't know if you took notes on that, but can you tell me what those 5 numbers are that compose the 5-number summary?
Yeah, so it's the minimum,
Okay.
the maximum, the median,
Okay.
I know there's the outliers if there's any on either side.
Okay, so the other two, one's Q1 and the other one's Q3. We'll just abbreviate those as quartile 1 and quartile 3. Okay, well done. It's nice when you get the first question because it's kind of easy, right? All right, so Emily, can you tell me what the minimum number is based on this data set?
Yeah, just give me one sec. Would it be 180? Yeah.
Okay, no jeopardy here. You're supposed to say it would be 180.
Oh, sorry. I just didn't know the numbers were sorted when I looked.
Okay. And the maximum?
21,147.
Okay, and then do you remember how to find the median?
Do you
What's
just
the formula for the median?
the median? That's the middle number, correct? Or is that the average? No, that's the middle number. You take the n numbers plus 1 divided by 2.
N plus 1 divided by 2. Okay, so in this case, my n, let me highlight these really quickly here. My n is 18. N equals 18. So how would you find it on this one?
You take 19 divided by 2, which would be 9.5.
9.5. So we're going to count to 9.5, and we're going to 1, 2, 3, 4, 5, 6, 7, 8, 9.5. So we're going to use both of those numbers. And then what do we do with those two numbers?
You add them up and then divide them by 2.
So 1651 plus 1953 divided by 2 works out to be 1802. Okay, well done. Okay, so now this is where it's really good to come to class because I'm not necessarily going to follow the book on this one. Now, so quartile 1, as I said earlier, think of this as the median of the top half. And we want, the question is, maybe I'll put this question down here. Do we include the median when calculating, I can't spell, Q1 and Q3? Okay, and the answer is it depends. Do whatever it takes to make the number odd. Okay? So if including the median makes it odd, include the median. If excluding the median makes it odd, exclude the median. Okay? So the nice thing is because I just want to make this odd. So if I take 1, 2, 3, 4, 5, 6, 7, 8. So if I include that one, now I've got an odd number, 9, right? 9 plus 1 is 10. 10 divided by 2 is 5. So then I can go 1, 2, 3, 4, 5. That becomes quartile 1, which is 735. I'm going to do the same thing down here. I want 9 here, so I include part of the number that we use to calculate the median. So 1, 2, 3, 4, 5. So this works out to be 4668. Okay. Now, there are other methods to do this. I'm only going to show you that you don't need to know this, but I'm going to use the computer method. Okay. The computer has a method which is called Quartile. Now there's three options here: exclude the median, include the median, or just plain old Quartile. Now, I always tell people use the Quartile. Array means your data set, so it's asking you to just put your data set in here, and then you press a comma, and then you can press 0 for the minimum, 1 for the first quartile, etc., etc. Okay. So the easiest thing to do here is if I F4 this, it puts $signs in there and it tells those numbers not to change. And then I can copy this down, and then all I have to do is change this 0 to a 1 and a 2 and a 3 and a 4. Okay. Now when you're doing, so the only reason I'm showing you this is right here. You'll notice these numbers are different. Okay. This is the by hand method. This is the method I'm going to test you on. And you'll also notice this is different. Okay. The other three numbers should be identical because they're going to use the exact same methods. Okay. Only reason I'm showing you this is to show you that there are other ways to find the quartiles. Okay. The by hand method is the one I want you guys to use. Okay. Unfortunately, we can't use Excel. If we did use Excel, I would not only show you that method, but I would expect it on a test. But since we can't use the test, the by hand method is the only method that we're going to do. But I just do want you to know there are other methods for finding these, but this is the method that I want you guys to use. So any questions on that so far? Okay. All right. So now we're going to check for outliers. Okay. And now this is going to be an interesting thing. We're going to compare these two methods. So let's see here. Victor, it must be your turn. Victor, do you remember what we need to do to check for in order to find outliers?
The first equation, I think, is Q1 minus 1.5 times IQR.
Okay, that was actually the second question, but you mentioned it. We need to find the interquartile range first. So do you remember what the interquartile range was?
No.
It was Q3 minus Q1. Okay. So in that case, this would be what?
4668 minus 735.
735. Now, just for fun, I'm going to do it for both of these different ways to calculate it. So you'll see the interquartile range that we did was bigger than the one the computer did. Okay. All right. Good job, Victor. How about Keaton? Victor actually did give the answer for the one of the fences, but do you remember the next step for finding the outliers?
I didn't write that part down yet.
Oh, you didn't write it down?
Nope.
Okay, Victor, give it to him again. I have a lower one, we're going to have an upper. What was the
Q1 minus 1.5 times the IQR.
And do you remember the other one?
It's Q3 plus 1.5 times IQR.
Okay. All right, now that you've got those nice formulas there, Keaton, can you figure out what the fences would be?
Yeah. Let's see. So it would be 735 minus 1.5. Uh, 733.5.
Oh, you forgot your interquartile range. It's 1.5 times the interquartile range. So that's that number we just found there, right?
Yeah, so it's a huge number.
Okay, so that's actually a negative number.
Yeah.
Negative 5,164. Can you give me the upper fence?
Yes.
And what numbers do I use for that?
You use 4,668 plus 1.5.
Times.
Is it the 3,933?
Okay, yes it is. No more Jeopardy. Okay? All my college students are big Jeopardy fans, I can tell. All right. So I got 10,567 now. Just for fun, I'm going to copy these formulas over here. Okay. Now, the question is, since we just did Keaton, Zach, do we have outliers? And if so, what are they?
Yeah, excuse me.
We're
It does
looking on this
not.
column. Say it
I
again.
don't. It does not look like we have any outliers because they'd have to be greater than negative 4670. Oh, actually, yes, we do. We've got the 9908, the 10,034, and the 21,147.
Okay, so we're using the numbers by hand. Okay, so
Okay, my bad.
you were looking at the wrong no ones there, but yeah. So so we don't have any numbers that are less than negative 5,000. So there's no lower outliers. No lower outliers. But as you said, so if we use this as our fence and we say anything bigger than 10,567, do we have upper outliers?
Yeah, just the 21,000. It looks like.
Yeah, the 21,000. So I'll put that as red there. Okay, so 21,147 is upper outlier. Okay, so we've got one outlier according to the by hand method. Now, do we have more than that, Rayleigh? Let's use these numbers over here, the computer numbers. Do we have any lower outliers, first of all?
No, we don't have any lower outliers, so we don't have any negative numbers.
No lower
But
outliers.
for upper outliers, we have there's 3 upper outliers.
3, okay. Because this is now my new cutoff, right?
Mm-hmm.
So we've also got these other 2 here, which are greater. Let's use orange, I guess. So I've got 3 upper outliers, which are, in this case, 9908, 10034, and 21,147.
Where did that new number come from?
So remember, we have different fences here. So because these numbers are different, I've got a different interquartile range. So notice this interquartile range is smaller than that one. And so if I use this number and this quartile, then I'm going to use this same formula here. This is Q1, which in this case is 71, whatever, minus 1.5 times this interquartile range, which is negative 4,670. And then Q3 plus 1.5 times the interquartile range, which is 3,600. Gives me 9788, okay? Now, I'm only showing you this just to show you the answers are going to be different, 1 outlier versus 3 outliers, depending on which method you do. This is the only method we're going to do in this class. But the computer would have 3 outliers in this case. Okay? Does that make sense?
Yeah, so I do have one question. When you're doing the limits for the outliers, can you go over that one more time? Sorry, I was doing some stuff.
Yeah. Yeah, so thank you for serving our state, by the way. You got your soldier helmet on and everything. All right, so yeah, so the formula for the fence is the lower fence is Q1 minus 1.5 times the interquartile range and Q3 plus 1.5 times the interquartile range. So we're going to be using these numbers here plus 1.5 times your interquartile range, plus or minus, depending on which side you're on. So on the low side it's minus, on the upper side it's plus.
Okay, thank you.
Okay. All right. So, okay, so this is the 5-number summary. Now the 5-number summary, we're always going to use the these 5 numbers. However, for the box and whisker, well, I'm going to show you. Let's see. You guys are going to have to draw this by hand. So here's what I would recommend. Hopefully we can make this so you can see them both, okay? All right, so, except for I can't see the things I want. Here, just a second. There, I need my line. Okay, so here's what I would do. First thing you're gonna wanna do is a scale. Now, this goes from roughly almost 0 to 21,000. So I'm gonna make a scale of every 5,000. So 5,000, 10,000, 15,000, 20,000. Okay. And I'm gonna go ahead, 5,000. 10,000. 15,000. 20,000. Okay. All right. Now, I'm trying to decide what I want to do first. So I'm going to start with the minimum. I'm going to draw a little tick mark at about 180, which is very close to 0. And then my next number is 735, which is going to be, I'm going to draw a little line right here at 735. 1802, it's going to be about right here. 4668 is going to be almost to 5,000. Okay. Now, so what I'm going to draw, these 3 numbers here, this is Q1, Q2, and Q3. That represents your interquartile range. And then I'm going to draw a whisker here. This is what I would call the box and whisker. So the whisker is going to go to either the minimum or the fence. Now, on the low side, I don't have any outliers. And so I'm just going to draw it to the minimum. Okay. Now, on the upper side, I do have an outlier. Okay. I got an outlier at 21,000. Okay. So 21,000, I'm going to represent as a little circle out here just beyond. So you can see that this is an outlier. However, I'm not going to draw So I did draw my line to the minimum. I'm not going to draw my line to the maximum in this case. I'm only going to draw it to the fence, okay, which is going to be 10,567. So what I'm going to do is I'm going to draw this whisker. It's going to go about just a little bit more than 10,000. What happened? Oh, it was because I drew a circle. I meant to draw a whisker. Okay. So this is method A. Now, if I were to do this with method B, which is the computer, okay, basically, well, this is going to look a little slightly different. I'm still going to draw my inner quartile range. So these are going to be so close to each other. I'm going to go ahead. I'm going to draw my box right here. These aren't going to be very different. Okay. Your median is going to be exactly the same, which will be here. We're still going to go to the minimum here. In this case, remember my fence is at 97.88, so I'm not going to go quite as far. I'm only going to go to about there. But in this case, now I should have 3 outliers, so I'm still going to have my 21,000 outlier. In this case, I'm also going to have 99.08 and 10,034. So I'm going to have basically 2 outliers here. Okay. So anyway, this is going to be, we'll go ahead and label our stuff here, cost of collision claim. And there you are, that's a box and whisker. Okay. Any questions on how to create a box and whisker diagram there? Okay. So just as a quick reminder, whenever you do this, you're gonna have to create a 5-number summary. And then you should figure out your outliers. And then the question is, really, is 21,000 an outlier? And it definitely is with either method. We might get a couple of other outliers with the computer method, but answer A, if this was a test question, answer A would be the one I was looking for. Okay.
So is that like the top whisker is the end of it, the max for A?
Yeah,
right there.
Whisker, that's not the max. That's the fence.
Fence. Okay.
And maybe here I'll just add a thing here. So this is the fence, and this is the max. Okay. So, and I can't remember what the book says. I think actually what the book says is instead of using the fence now. So I'm going to be slightly different than the book. I want you to draw the whisker to the fence if there's an outlier. Go ahead and just draw it to the minimum in this case because we won't have any outliers on the low side. I think the book says go to the value before, which would be 10,034, which is actually really close to the fence anyway. That's another method, but the method I want you to do is draw the whisker to the fence if you have an outlier. Otherwise, you use the maximum or the minimum. Is that clear?
Yes.
Okay. Of course, the other tricky thing is finding these 2 medians. So I kind of wanted to see if I can, let's see. I wanted to do one more if we could. I know we've only got 5 minutes left. Okay, so yeah, a lot of times you're going to compare a university A to a university B. let's see. Let me pick on somebody here like Sarah Larson. Can you tell me what you would do first? We're going to try to do this in 4 minutes really fast. What would you do first if you were trying to do a box and whisker on this?
I would sort the numbers.
Okay, which is nice that we can do it so fast in Excel. Okay. Oops, that put everything at the bottom. Okay. And then Whitney, do you remember what the 5 numbers are that I'm supposed to keep track of?
Yeah, we want to get the minimum, the quartile one, median, third quartile, and the maximum.
And then Mia, can you give me the minimum and the maximum?
The minimum is 69 and the maximum is 127.
Perfect. And in our data set, we've got, oops, what happened here? We've got 30, okay? So what value, Kylie, would be the median? What value would I use if my n is 30? And Kylie, you're on mute, I think.
Divided by 2, which is like 15.5.
15.5. 1, 2, actually we can do it. It's going to be these two values here. So the median in this case is what?
$103.
103.
Thank you. How about Keaton? Do you know how to find the first quartile?
Yeah, the first quartile is
We're going to use those numbers for that. So 15 plus 1 is 16. 16 divided by 2 is,
say it again.
what's 16 divided by 2?
Is 8.
8. So we're going to count down to 8. 1, 2, 3, 4, 5, 6, 7, 8. So my first quartile is
91.
And then quartile 3, do you know what that value is, Christian?
That would be from the median from 16 to the end.
Yep, so 1, 2, 3, 4, 5, 6, 7, 8, and that would be
109.
109. I meant to highlight that. The interquartile range is what, Broderick? Are you there?
Yeah, I'm not gonna lie, I'm not 100% sure on that right now.
Okay.
Sorry, we're driving.
You're busy. Oh, you're driving. You shouldn't be on your phone if you're driving.
I'm just a passenger, but we're watching.
Oh, you're a driver. Okay. So Alejandra, do you know really quick?
I don't, sorry.
It's going to be Q3 minus Q1, which is 18. How about Jed? Can you tell me the lower fence?
Yeah, sorry, I was just getting unmuted. So to find the lower fence, it would be Q1 minus 1.5 times 18.
Okay, 64. Do we have any lower outliers?
No.
No lower outliers. And then Matthew and Judy, how to do on your name?
You did great, sir.
Sweet. So what's my Q3 or what's my upper?
So your upper would be 109 plus 27, which works out to 136.
Okay, do I have any upper outliers?
Looks like we do not.
Do not. So I don't need to use my fences. And then, you know what, I'm going to cheat since we're out of time. I'm going to use the Box and Whisker maker here just to show, dang it, why does it keep doing that? I will just show you this only because they do have a Box and Whisker chart maker with Excel, but you can't use it on the test. And it's vertically oriented. The only thing I would say that would make it better is if it were properly labeled. What does this data represent? These are IQ scores. Oh, actually, let me show you this really quickly. If I were to move these next to each other, you could actually, and Excel doesn't care if they're sorted, insert Box and Whisker, all charts, Box and Whisker. They didn't used to have this, by the way. This is nice because they put them in different colors, but you could put IQ scores at 2 universities. The only thing I would say here, that one doesn't mean anything. You'd add some axis labels here, and you would put University A, University B, and you would put IQ scores. And you can see what's interesting about this is you can see the whiskers are longer, and you've also got a bigger interquartile range at A than you do at B. So there's less variation in B than there is A. You'll also notice the computer puts an X there. Now, if that line represents the median, what do you think the X represents? Any ideas? I know I need to let you guys go.
Could it be the mean?
It is the mean. Now the mean's not part of this, it's only the median that we use, but that's kind of a nice little bonus that Excel gives you. So anyway, I don't care if you do it horizontally or vertically. It's usually a little easier to do it horizontally for students, takes up a little less paper. But either way, it's fine. I kind of like the vertically better, but either way, I don't care. So, okay, homework is going to be the rest of 3.4 and all of 3.5, and quiz will be that as well. So, any questions before I let you go?
I do have one question real fast. So when you're finding the lower fence and upper fence, you take the first or say lower fence, you take quartile 1 and you subtract it by what?
1.5 times the interquartile range.
Oh, it's always 1.5 then, no matter what.
Always 1.5. Okay. If I had more time, I would explain why that's always 1.5. I'll try to explain that on Tuesday, but you probably wonder why that 1.5 is there. Here, I'll explain it really fast. This represents 25% of your data. Your interquartile range represents 50% of your data. This fence represents the other 25% of your data. So the idea here is if we go twice as far, or 1.5 times the interquartile range, if we find any values beyond the fence, that's why those are outliers. So you can see in this case, we've got a short whisker on the left and a long whisker on the right. And then depending on whether you're using B or A, 1 or 3 of those. And so if something's more than 50% beyond this, which is only supposed to be 25%. So if we double that and go 50% and you still have data beyond those, that's why those are outliers. So that's where that 1.5 comes from.
That makes sense. Thank you.
Okay. Any other questions? All right. Well, I'll see you all tomorrow. So have a great one.